Good morning, students. Hope you are all well. In today's session, we will discuss the first part of the mole concept, that is, Dalton's atomic theory and Avogadro's hypothesis. So, let's begin with the Dalton's atomic theory. The main postulates of Dalton's atomic theory are matter is made up of very small, indivisible particles called atoms. Atoms of same element are identical in all respects, that is, size, shape, and mass. Atoms of different elements have different masses, sizes, and also possess different chemical properties. Atoms combine together to form molecules. Atoms always combine together in simple whole number ratios. Atoms of same elements may combine together to form more than one compound. An atom is the smallest particle that takes part in the chemical reactions. An atom can neither be created nor destroyed. Children, if we study these points carefully, then we will find that Dalton's theory has well explained all the laws of chemical combination, which we have already discussed in our previous sessions. If you look at the point 1 and point 8, both of these points they employ the law of conservation of mass. Point 5 employs law of constant composition as well as law of reciprocal proportions because it says that atoms always combine in simple whole number ratios. Similarly, if you look at the point 6, then it implies the law of multiple proportions, that an element is always made up of same elements combined in the same fixed ratio. In spite of all this, there are many limitations to this theory. Let us study each limitation one by one. It failed to explain the law of gaseous volumes. It could not explain why atoms of different elements have different masses, sizes, and valencies. It could not distinguish between the ultimate particle of an element and a compound. Why do atoms combine with each other? Dalton was unable to answer this question. What is the binding force between atoms and molecules due to which matter exists in three physical states in nature? Even this question was not answered by Dalton's atomic theory. Here we have seen that Dalton theory was unable to explain the Gay-Lussac's law of gaseous volume, but it explained all other laws in very effective manner. This drawback was overcome by a scientist named Avogadro. Firstly, he distinguished between an atom and a molecule. According to him, an atom is the smallest particle of an element which can take part in a chemical reaction. It may or may not be capable of independent existence, while a molecule is the smallest particle of an element or compound which is capable of independent existence. Next, he proposed a hypothesis, law, or principle to establish the relationship between the mass of a gas and its volume. The statement of Avogadro's hypothesis is that equal volumes of all gases under similar conditions of temperature and pressure contain equal number of molecules. This hypothesis became very important and finds many useful applications. Now, let us study the applications of Avogadro law. The first application is in the calculation of atomicity of elementary gases. For this, we have taken hydrogen gas and chlorine gas. When these gases combine together, they produce HCl gas. According to the reaction, H2 plus Cl2 gives 2HCl, and as the Gay-Lussac's law says, one volume of hydrogen reacts with one volume of chlorine to form two volumes of hydrogen chloride. If we imply Avogadro's law in this situation, then according to Avogadro's hypothesis, equal volume of gases contain equal number of moles. So we have n molecules of hydrogen, n molecules of chlorine and 2n molecules of hydrogen chloride. If we assume the number of molecules to be 1, then we have 1 molecule of hydrogen, 1 molecule of chlorine and 2 molecules of hydrogen chloride. For finding the atomicity, we have to take 1 molecule of the product. So, we will multiply all these molecules by 2. Now, we have half molecule of hydrogen, half molecule of chlorine and 1 molecule of HCl. Now, we know that in 1 molecule of HCl there is 1 atom of hydrogen. Suppose the atomicity of hydrogen is N, then N multiplied by half H2 is equal to 1H. This 1H we have taken from the HCl. So here N comes out to be 2. So the atomicity of hydrogen is 2. Similarly, we can calculate the atomicity of chlorine or any other gas in any of the reactions. The second application of Avogadro's law is to find relationship between molecular mass and vapor density of a gas. Vapor density is equal to density of the gas divided by density of hydrogen. Now, we have already studied in our previous classes that density is equal to mass upon volume, means a given mass per unit volume. That is called density. So, we can amend this formula and we can write vapor density is equal to mass of VML gas at STP divided by mass of VML hydrogen at STP. Now, according to Avogadro's law, equal volume of different gases at STP contain equal number of molecules. Here, The volume of hydrogen and the gas which we have taken is Vml. Both are same. So they will have equal number of molecules. Let the number of molecules is n. So our formula becomes mass of n molecules of the gas divided by mass of n molecules of hydrogen. If we assume number of molecules to be 1, then the formula becomes mass of one molecule of the gas divided by mass of one molecule of hydrogen. We know that one molecule of hydrogen contains two atoms of hydrogen and the mass of hydrogen molecule is 2. So our formula becomes molecular mass of the gas divided by 2. From this, after cross multiplication, we get 2 into vapor density is equal to molecular mass of the gas. So, in this way, with the help of Avogadro law, we have found the relationship between vapor density of a gas and the molecular mass. The third important application of Avogadro's law is to find relationship between mass and volume of a gas. Just now we have seen that molecular mass of the gas is equal to 2 into vapor density. So, the formula of vapor density is mass of Vml gas at STP divided by mass of Vml hydrogen at STP. So, our formula becomes 2 into mass of 1 liter of gas at STP divided by mass of 1 liter of hydrogen at STP if we take the volume to be 1 liter. Now, from experiments, we know that the mass of 1 liter of hydrogen at STP is 0.089 grams, which comes out to be 22.4 into mass of 1 liter of gas at STP. Or we can write molecular mass of the gas is equal to mass of 22.4 liter of the gas at STP. From this, we can say that one molecule of a gas occupies 22.4 liter volume at STP. So, through this, Avogadro was successful in establishing a relationship between the volume and the mass of the gas. STP is standard temperature and pressure. The value of temperature is 273.15 Kelvin and that of pressure is 1 atmosphere. That's all for today. In our next session, we will discuss about the Avogadro's number and relative atomic and molecular masses. Till then, stay home, stay safe. Thank you.